rule, okay, updating the system. Updating the system for with parameter theta. Why? For example, we want to know what is the weight, okay? This is the operation in mathematics in your computer. Once we will do the make a program in Python. This is the iterative process. Iterative. Remember iterative. This symbolic 2 colon, okay, equal sign represent the iterative process. And this is shown in start in morning. We opened our shop, only 50 rupee, okay, cash is there. Suppose this theta, this is the 50 rupee. Cash is 50 rupee. So, you are, with the passage of time, okay, I will go with other way. For example, you are doing a job in a bank at a cashier point. People are withdrawing their salaries. In start, it's too much. Okay, because I want to reduce the error. That's why I will use the negative sign here. So, people are withdrawing the salaries. Maybe at start it's 1 lakh, maybe it's 10 lakh, maybe only no person will draw salary. It can be also possible, but if it is a day on which people will withdraw the salaries, we will start with this value. Gradually, first person will come, he will withdraw 50,000 or 1 lakh rupee. This is some kind of a scalar value alpha. That is the stepping value. That each person will draw maybe in the range of 1 lakh. Someone will draw 70,000, someone will draw 90,000, someone will draw maybe 1 lakh 10,000, around the 10,000 or lakh rupee, okay? And what we will do next? We will see someone is of high rank, someone is at middle rank, someone is at, okay, like me, okay, so getting low salary, someone is working at the level of rector, getting very high salary. So things will change, and this change will be done with the help of cost function. Change. And each iteration, each iterative process, at each withdrawal, this value will be updated. Okay? Next, for example, this is the theta 0, then it will become theta 1, then it will become theta 2. Weight.
Gradually reducing.
Yeah, gradually reducing, okay? You are getting the new weight, new prediction. And until convergence. Thank you so much. So, this is the convergence. I will tell you at the later stage. So, in this situation, you are, okay, equation will become like alpha is a step function. I will explain this alpha. Okay, it is playing a big, for example, one person come and he said that give me a 50 lakh. Okay, then alpha is some kind of a step function. I will explain it. Okay, for example, if you are standing at the top of this building, you will go step, little step by using the stairs. If you will jump directly from that, then you will, okay, in danger. You will put yourself in trouble. Are you getting my point?
Yes.
Alpha is some kind of a scalar. The size of this step, it can be, and the change, okay, here, This is the partial derivative. It is kind of a gradient and it is of the cost function. And in this cost function, I told you people we need to minimize this one. This one. If you studied the basic mathematics in your intermediate OA level study, you know the concept of minima and maxima. There are two things, global minimum and global maximum. Okay, so global minimum is this. For example, this is one campus of Park, Austria. Okay, for example, we are talking about the PFIST. Only one department, IT and CS. All the person received their salary, then minimum is achieved. This is known as local minimum. Local minimum. If all the campus employee got their salary, then global, okay?
Global minimum.
Global minimum can achieve. Global minimum. So I will explain this concept a little bit later with the graph. The things are getting big. So this is the thing, okay? For this purpose, you need to consider, you remember you are considering the derivative equivalent to consider the derivative equal to 0. Okay? Because you consider that, okay, there is no further change, consider 0, then the rest of the equation you get the value of the parameter. So let's do this. For example, here in the situation, norms, this norms. Yeah, you are tired, I think. Come on, okay.
Yes,
We
come
need
on.
breaks. Huh? Okay, just one last. This is the cosmetic strategy. So if we apply the derivative, of course, just consider this for getting the minima, you are considering this whole first order partial derivative equal to 0 because you are minimizing it. You are getting rid of the system. So 1/2 as it is, and here, okay, by getting this one, you will see, you can write so you will get rid of this, you will get this equation. Okay, I will speak out after the break. 2 minutes.
Thank you.
You're welcome. Okay, there, see, we need to expand it a little bit. Basically, we apply a partial derivative on this, and wherever theta is involved, we need to differentiate it. For example, if there is a x square plus y, we want to, this is a function, please welcome. I'm so sorry, just I thought, you can take your time, okay, no need to worry, never, okay, no need of rush, just enjoy the tea and once sit in a class, just relax your mind, so that you can learn something. Okay, actually, I was talking, I did little mistake because at runtime I closed it, my main focus over there, but I did not expand it, or you can say get its a complete partial derivative. The thing is that here, if this is some equation, I want to apply some derivative on this with respect to x, then it should be, if there is a scale, it should be like this, 2 x square plus y, 2 minus 1, and we are considering the partial derivative with respect to x, then partial derivative of inside now x square plus partial derivative x y. So here, yes, this can be written as x square plus y, and this, of course, it will be 2x, and this will become 0, so we don't need to mention it here. Remember this thing. And in this case, if I consider it okay. Oh, okay, thank you so much. That's fine. Now, let me rewrite again. Okay, one more thing before proceeding to this. Can be written like this. Product of two, okay? Or we can also write this scale if we just consider the one, okay? Same thing. Okay, let me apply partial derivative on it with respect to theta, weight parameter theta. So here our hypotenuse, okay? So, or you can say this one is the cost function. And for simplicity purpose, okay, though there is a 1/2, but I will see it at later stage. So now we can write it to x minus y, and what we will do here, the technical thing is theta naught x naught plus theta 1 x1 plus theta 2 x2 plus theta n xn minus y. You got this or not? Basically what I did, I like here I considered the inner things, and this was the, okay, for getting the partial derivative of inner values I considered it, but here our inner value, that is though hypothesis, is the function of weight parameter theta, and what I did, I expanded. Basically this is nothing else except the hypothesis value in expansion form, okay?
Yes, sir.
Inner, okay, see, this is the scale, okay? We can write it, this is the first, and for getting the theta weight parameter involved, then we need to get the partial derivative again for the inner values, and for getting the inner values partial derivative, I expanded it. Is it clear? And you know what will happen? This whole segment, okay, you can say it's the, if you will have theta, then you will consider only x here, or you can say big X.
Big X.
And for y, we say it's 0. Do you know what I did? Understand it or not?
Yes. Y.
I just considered, see, if there is x, y, I want to take the partial derivative of this xy. Here, basically, x is theta. Suppose this one is the y, theta and x. So, I want to illustrate it for you people, but sometimes this is good. So, answer is what? Y only. No? Get it or not? No one? Not clear?
dy dx of x is
Not
1.
clear.
Not clear. Yes, yes, please.
dy dx of x is 1.
Yes, okay, good.
X-axis.
Yeah, see this, see, please. No issue. If you have some 2x,
Yes.
you want to,
Derivative.
simple, okay, partial derivative is the single variable. No need to worry. You want to differentiate it. What will the answer here?
2.
2.
2.
Is it okay?
Yes.
We can write, if we are talking about the partial derivative, okay, we are talking partially for the x value, and this here, what will happen basically? 2 partial x and this x, it will be cancelled out, so we will get 2 like this. But if we will have xy, we are applying some partial derivative here. What will happen? We will keep y as a constant. We do not need to bother it. Okay? So x, partial x over partial x will be eliminated. We will get only y. Similarly, in case of this, if there is a theta x, like this is the hypothesis. As I told you, we can write this hypothesis, okay, like theta x, theta transpose x, theta x transpose, it does not matter, okay, just for generality purpose we can write it. So, what will the answer here? Only x. And if we are considering this partial derivative of y, answer will 0. So in previous case, this case, we apply partial derivative with respect to weight parameter theta of this function. This is a square, okay, according to the formulae. So 2 is here and the first inner value can be kept as it is. And again, there is a involvement of weight parameter theta. We are expanding this and we know this is equivalent to what? Theta x, and minus y will become, this is not the multiple of theta, so we will make it 0. In this case, this is 0 and the theta, okay, it is like here, it will be cancelled out, only 2 left, here only x left. It is okay?
Yes.
Any query, please?
Yes.
No? Thank you so much. So, in updation, okay, you can say update the system until stable, or you can say convergence. So it's like iteration process first like this, started step function, and of course it will involve some kind of, so okay, values, or you can say if you are talking about the complete set, then you can say ij equal 0 mn here. One to n such that a theta of x minus y x, this is the thing in this case for features, or you can if you will consider the examples, too many single thing, okay, single unit house, then of course you will consider the features of that house, and in this case lower one represent what? Upper one is representing number of examples, okay? If you will consider the 4 houses, upper one, this iota will represent 4, and if you talk about the features of some house, then J will show. So here it is the J, then of course it will go to the N features, and of course here you can say J if you are talking about the
features.
Also number of features. So this is the, you are talking about the, okay, and this situation, this. If you will, this is the single unit, okay, house, you are just normalizing, or even you can, for simplicity, you should not write anything like this, okay, just consider this. A moment ago, what I did, this is the equation of normal, okay, equation of you know, there was 1/2, I cancelled out this, okay, you got this point? This 2 was cancelled out with the, we considered 1/2 artificially, somewhere here. Basically, this one, yeah, here, this is the cost function. Basically, cost function is what? Cost function is the norms of hypothesis minus predicted value, or you can say active value y. So we considered, and we considered 1/2, and once we substituted the value of this cost function after getting the partial derivative, and then this 2 will be cancelled out, okay, in the further case. So this 1/2 will be cancelled out after getting the partial derivative of the cost function. So you will get this simplified equation of normal.